people, once again welcome back to the class where we are together again once again, and now we are going to solve the questions that will be based on the JEE main pattern for nothing but the chapter nuclei. As you know that we have covered the chapter, we have covered the theory portion, and also we have done the CBSE questions, NEET questions. Now it's time to just see what is the level of the JEE main questions for the chapter nuclei. So let me just see what is the first question before us. Okay. So I can see that we have been given 4 figures over here, and if I read out the question, I can see that we have been given that a radioactive sample consists of 2 distinct having equal number of atoms initially. The mean life of one species is tau and that of the other is 5 tau. The decay products in both the cases are stable. So a plot is made of the total number of radioactive nuclei, that is N. You can see easily that N has been written over here. So that means your N is nothing but the number of radioactive nuclei. The plot is given between the total number of radioactive nuclei as a function of time. So this tau is nothing but, where is the time? Now which of the following figure best represents the form of this plot? We have to tell them which figure is the best figure according to the question, the situation that has been given over here. We know that if we are having a radioactive substance before us, it is definitely going to decay after some time interval, that is T. So we also know that after one half-life, it becomes totally half of the initial amount of the radioactive nuclei. So if I am saying that however the situation is, the radioactive nuclei is going to decay, it is not the case that it will be staying continuously, it will be increasing by the time. No, that is not going to happen. Definitely by this situation I can see that your N, that means total number of atoms that has been left after the decay, is nothing but the total number of atoms that is going to decay will be decreasing exponentially, because you can see that e raised to the power minus lambda t, where t is your time and your lambda is your decay constant. So that means your atoms are going to decay exponentially. If I just see for the figure number 1, I can see that at particular interval of time, this number of nuclei is constant, right? Neither it is increasing nor it is decreasing by the time. But this cannot happen that the number of nuclei will remain same, because we know that if we are having a radioactive nuclei, it is start going to decay at the very beginning. So that means this cannot be the case of this situation, because in the question we have been given that the mean life of the species is tau and that of the other is 5 tau, and the decay in the decay products in both the cases are stable. Well, if you are talking about the decay products, that means your radioactive species, the species that has been given in the earlier, it is definitely going to decay. Now if I will see for the second figure, I can see that initially it was decreasing. By the time tau, it started increasing. After the mean life, it started increasing. Then again it started decreasing. As I have told you, the number of nuclei cannot be increased in this case. Number of nuclei will definitely going to decrease according to this situation. So that means it cannot be the correct figure according to the situation. Let me just move to the B figure. Again in this case, you can see here, earlier the number of nuclei was decreasing like this. After the time interval tau, it started increasing. You can see that the number of nuclei started increasing. Again it started decreasing. But as I told you, it cannot increase, so we will say that this cannot be the correct option. So as you can see, only one option is left, but we are going to verify for this also. You can see here this n is decreasing as your tau, that means your time interval is increasing. So this is definitely the case of ours, that means it is just decreasing exponentially. That means this must be the correct graph. So one thing, the explanation that I can give you for this is nothing but that the number of nuclei, the radioactive nuclei in the process of decay will neither increase nor it will remain constant, as you can see in the case number A. It will definitely going to decrease, so your option, the correct option is nothing but the D. This is the correct answer. So yeah, we are now done with this question. You can see how you can relate your knowledge with the question that has been given over here. I think some people might get confused at this situation where you will see this tau and 5 tau. But you do not get to worry about this situation. You just have to focus on the graphs that has been given. While we know that the basic of the chapter is that radioactive nuclei is going to decrease exponentially by the time. So that means this situation must be satisfied by any of the graph that has been given over here. And so what we have applied over here, and finally we have concluded that this is our correct option and this is the correct figure for the situation. Now as we have done this question, we will be now moving towards the next question, that will be the question number 2. Okay, so in this question I can see that half-life of a radioactive substance A is 4 days. Let me just write over here. The half-life of A is 4 days. Now the probability of a nucleus, the probability that a nucleus will decay in 2 half-lives is what? So we have to tell them what will be the probability of a decay, of a nucleus decay in the 2 half-lives. We know that suppose if initially we were having n-naught number of atoms. So if we are having n-naught number of atoms after 1 half-life, that means after 4 days it will become half, because I told you that after 1 half-life they are going to just become half. So it will become n-naught by 2. Now again, because in the question we have been given for the 2 half-lives, so the second half-life will be what? Again after 4 days it will become half of this. So that means it will become n-naught by 4. So your total number of atoms that are left undecayed, it is 1/4 of original number of atoms. Now if I speak about the atoms that are decayed in the 2 half-lives, in 2 half-lives, that will be, initially it was n-naught and after the 2 half-life it has become n-naught by 4. So your total number of atoms that has been decayed will be n-naught minus n-naught by 4. So that means you are having your number of atoms that is left with you that has been decayed are nothing but the 3/4 of initial number of atoms. These are the number of atoms that has been decayed. So the probability that a nucleus will decay in the 2 half-lives will be nothing but the 3/4. So let me just see whether there is any option. Yeah, I can see that option number B. So your probability will be nothing but the 3/4. What you have to just think about this question is that if you are having your n naught number of atoms initially, so after one half-life it will just become half of it. When it becomes half, it will be saying that it became n naught by 2. Again after one half-life, that means after 4 plus 4, that means total number of 8 days. After 8 days, it will again become its half. So half of n naught by 2 is n naught by 4. So this is the number of atoms that has been left with you undecayed. Now if we want to find the probability of number of atoms that has been decayed, that will be n naught minus n naught by 4. Initial minus final. Initial, because initial amount was greater and final amount was lesser. So the total number of atom that has been decayed will be this amount. The difference between that, and that is what we have did here, right? So this was your question, because I know that this question might be looking very simpler to you, but if you will be just looking at the question, you might get confused with the probability. So let me just tell you what is the probability. The probability is nothing but the final minus original, but here we know that initially we are having n naught numbers of atom and finally we are having n naught by 4. So the total number of atom that has been decayed must be 3 by 4 n naught, and this is the probability that has been done after the 2 half-lives. So you need not to worry if you are getting such question, and if you can see that in the 2 half-lives your probability is just same as you have come out to be, so you just have to tick over that option. So yeah, we are now done with the question, that is the question number 2. Let me just see. You know what, the case is that people think that because this is the JEE main level, so the level will be at this much portion. So your level will be at this place. But let me just tell you, in the JEE main and advanced also, examiners set up just a simple type of question just to test your basic knowledge. So that means if you are clear with the basic concept, your level will be that much higher. So you should not be just thinking about that, how easy this question is, this cannot be the answer of this. So you just have to focus over one thing. There might be the question which will be very much easier and simpler. Okay? So now we will be moving towards the next question, that will be the question number 3. We have been given that a radioactive isotope is being produced at a constant rate x. Half-life of the radioactive substance is y. After some time, the number of radioactive nuclei become constant. So what is the value of the constant over here? Now let me just start by telling you this question. As you know that we have been given the half-life as y. So let me just write this T is nothing but the y. Also we have been said that a radioactive isotope is being produced at a constant rate x, and it is because we are having our radioactive substance before us. Let me just say it is A and it is converting into B. According to the question, we can see that it is just transforming into one stable nuclei. When we say that A is being converted or A is being decayed into B in this half-life, then we can say that the rate has been given over here. So the rate over here is x. Now to just get the constant number of radioactive nuclei, the activity should be for constant number of radioactive nuclei. In the question we have been given R is nothing but the x, activity is nothing but the x. So your x equals to n lambda. Now from here you can see that your n is nothing but x upon lambda. What we have to tell in the question? What is the value of the constant? So to find out this value, basically we are finding out this number of atoms that are constant over here. So x by lambda. Now we know that we have been given this half-life. This is nothing but the half-life. It is given as y. So now you know that we are having one formula before us, and that formula is T equals to log 2 by lambda, where lambda is your decay constant. Now you know that we are having lambda over here. So from this equation we are having the value of lambda as log 2 upon T. So let me just put this value over here, x upon log 2 upon T. Now you know that this T is nothing but the half-life. In the question we have been given that the half-life is equals to y. So we are just going to put y in place of T. So if you will be putting it, you will be having x upon log 2 upon y, or you can write it as xy upon log 2. Now let me just verify whether there is any option which is having xy upon log 2 as the constant. So yeah, I can see that option number A, we are having xy upon lambda 2 as the answer that we have gained here. So again, this question was very much simpler, but the thing that you have to focus over here is that here we have to start with the activity. We have been given the formula, we just know the formula, and we have been given that a radioactive isotope is being produced at a constant rate x. That means the activity has been given. So definitely you are going to apply the formula R equals to n lambda, and now because you know that we have been given this value as x, so you just have put this value over here, and so we got our correct answer. Now let me just move towards the next question. That will be the question number 4 of the session. So yeah, this is your correct answer. You can tick over here. This is the correct one. Okay. So now in the next question, I can see there is a question related to the alpha and beta decay. If 92 uranium-238, that means isotope of uranium, it is changing to astenine, that is atomic number 210 and mass atomic number is 85, mass number is 210. It is decaying by a series of alpha and beta decays. So we have to tell them how many there are how many number of alpha decay and beta decay in this process. Again, this is a very easy question. Let me just start, and I know that you will be doing along with me in your notebooks, and you are going to solve it just before me. So let us just start. We are having a uranium isotope and it is changing to this 85 and 210. Now you know that in the case of alpha decay, what happens? Mass number is reduced by 4 and the atomic number is reduced by 2. In the case of beta decay, mass number do not change. So if it is A, it will remain A, but the atomic number, it will be increased by 1. This is the case of beta decay. Now in the question we have been given only this, and we have to tell them how many number of alpha and beta decay would be happening. So let me just tell you, earlier it was 92. Let me just take the case of atomic number. Earlier it was 92. So if the alpha decay would be happening, it will be, let us just first of all suppose that number of alpha decay equals to x, and number of beta decay equals to y. Now in this case you will see that we are having number of alpha decay as x, number of beta decay as y. As you know that if I'll be taking the, just come here, first of all I'll be considering the case of atomic number. You know that atomic number is going to be reduced by 2 in the case of alpha decay, and in the beta decay it will be increased by 1. So that means if I'll be taking the case of atomic number, earlier we were having 92, it is going to be reduced by 2 in the case of alpha decay, because we have considered the number of alpha decay as x, plus because in the case of beta decay it is going to be added by 1, plus 1 into y you can say is equals to 85. This is your equation number 1, or you can further solve it as minus 2x plus y equals to 85 minus 92. So you will be having minus 2x plus y equals to minus 7, right? Now if I'll be taking the case of mass number, that means A, as you know that mass number in the case of alpha decay will be reduced by 4, and in the beta decay it will remain same. So earlier it was 238, just see here, earlier it was 238 and after the decay it has become 210. So we will be writing it as 238 minus, in the case of alpha decay it will reduce by 4, so you are putting minus sign over here. So minus 4 into x, because it is reducing by 4. Now as mass number will remain same, so we are not going to touch the mass number over here. So plus 0 you can put, because there is no change, it is equals to 210. So you will be having minus 4x, or you can just say 238 minus 210 equals to 4x. So if you will be solving it, you will be having is it correct or not? 238 minus 210 equals to 4x. So 8 and 3 minus 1, it should be 2. 28 equals to 4x. So from here your value will come out to be x equals to 7, right? So now if I'll be putting this x equals to 7 in this equation, let me just consider this equation as equation number 1. So if you will be putting this value, you will be having minus 2 into 7 plus y equals to minus 7. So you are having minus 14 plus y equals to minus 7, or y equals to 7. So both the values, that means x and y, has came out to be 7. And you know that you have considered the number of alpha decay as x, that means it has came out to be 7. Similarly your y has came out to be 7. So okay, now we just see the number of options. I can see that option number B, that means both are 7 and 7. That must be the correct answer for this question, right? So this was the way how did we started the question and how did we proceed and how did we reach to the answer. Now let me just move towards the next question, that is the question number 5th. Alright, so I can see that a radioactive element X converts into a stable element Y. If the half-life of X is 2 hours, initially only X is present. After time t, the ratio of atoms of X and Y has came out to be 1:4. Then t in R is what? So find out the time. We have to find out the time in this case. So let me just rub the board first and then we will be starting it. As we know that we have been given the half-life of X, T of x is 2 hours. And we have been given that x is being converted into the y. Yeah, so initially only x is present, definitely only x will be there. After time t it is going to decay into y. So we can just see that after one half-life what will happen? Suppose initially x were having n naught number of atoms. X will be having n naught number of atoms. Right? So let me just say after one half-life what will happen? Initially it was n naught. After 2 hours it is being converted into n naught by 2. Right? So again, because what are they asking? Yeah, it has becomes to n naught by 2. Now this is the case of x, that x is been converted into n naught by 2. Now let me just convert this nx n naught in place of, I'll be writing nx. That will be easier for you to understand. Now because x is being converted into y, so we can say that if nx is nx by 2, so your ny will be n minus nx upon 2. Your ny will be remaining of that. That means initially it was nx and finally it was nx by 2. So the ny, that means the number of atom that has been decayed will be ny. So that will be nx minus nx by 2, that means it is nx by 2. So if I will be finding out the ratio of nx upon ny, it will came out to be 1:1. Nx by 2 upon nx by 2, 1 by 1. Now let me just check for the another half-life. After second half-life, what will happen? Earlier it was nx, after one half-life, that means after 2 hours, it has become nx by 2. Again after one half-life, what will happen? That means again after 2 hours, it will become half of this. So it will be nx by 4, right? So your nx has came out to be 1 by 4 of initial atoms. Now in this case, your ny will be what? Nx minus nx upon 4. That means 3x upon 4. So now if I will be finding out the ratio will be nx upon y will be nx upon ny. So nx by 4 divided by 3x by 4. So it is came out to be 1 by 3, right? So now in the question what I can see, the ratio has been given as 1:4. Now you are having 1:1 as your ratio, 1:3 as your ratio. To just get the 1:4 ratio, I will be proceeding towards the next half-life. So in the third half-life, what will happen? Earlier it was nx, then it became nx by 2, then it became nx by 4, and then it will become nx by 8. Half of this again. So total your time will be 2 hours, 2 hours, 2 hours. That means total 6 hours. 2 hour, 2 hour, again 1 2 hour is added, so total 6 hours. Now your atoms of x in this case will be, earlier it was nx, now it is nx by 8. So your ny in this case will be nx minus nx upon 8. So that means your number of y is 7nx upon 8, isn't it? Right? So now what we'll do, we will again find out the ratio of nx upon ny. So your ratio in this case will be nx upon 8 divided by 7 upon 8. Let me just do nx upon 8 multiplied by 8 upon 7 nx. So that means you are having 1 upon 7 as your number of x to the number of y. Now what you have to focus over here, in the question we have been said that the ratio of x and y is 1:4. But we have seen that in the first half-life we have got 1:1 as the ratio. In the second half-life 1:3 is the ratio. In the third half-life 1:7 is the ratio. So definitely you can see over here your question, in the question the ratio is 1:4. We have been given in the question that this is nothing but 1:4. So you can see your 1:4 is coming into the range of 1:3 and 1:7. That means your time interval should be, earlier it was 2 plus 2, that means 2 half-lives. That means total 4 hours, right? In this case, your total time will be 2 plus 2 plus 2, that means 6 hours. So here t is equals to 6 hours. Here t is 4 hours. So that means your 1/4 lies in the time interval that will be between the range of 4 hours and 6 hours. So now I'll be checking out the options that is available before me, and I can see that option C is the correct answer. Appropriately it has been given that the time interval will be between 4 and 6 hours. So definitely we are getting the correct answer. So this is the correct approach to the question, correct approach to the answer, and definitely this is the correct one. So now let me just move towards the next question, and for moving that I will be preparing board for you. Okay, so now after completing the question number 5, let's just move towards the next question, that will be our question number 6 of the session. So I can see that we have been given that assume that neutron breaks into a proton and an electron. Suppose, let me just make a neutron over here. It is a neutron and it is breaking down into a proton. So this is proton and this is my electron. So the energy released during this process is that we have to find out. So what we have to find? The energy released. Yeah, okay, I can see that mass of neutron has been given, mass of proton has been given, and the mass of electron has been given. So I know that we are having one formula related to the energy and mass, and that formula is none other than E equals to delta M into C square, where delta M is nothing but your mass defect. So now if you want to find out the mass defect, what you are going to do? To find out the mass defect, that means delta M. That will be, earlier it was neutron and it is breaking down into proton and electron. So the mass defect will be MP, that means mass of proton, plus mass of electron minus mass of neutron. Let me just tell you why we have written such statement. Because as you have studied in the binding energy and you have studied about the mass defect, you know that when fusion is taking place, you can say, if we are making one nucleus, so the nucleus will be having lesser mass than the individual sum of protons and neutrons. As you know that nucleus is made up of neutrons and protons, so when the sum of mass of proton and the neutrons is greater than the mass of the nucleus. So that at that time we say that where did this mass go? So the mass has gone into the form of energy. So we can say that mass defect is nothing but MP plus ME. Similarly, because in this case this is breaking down into these two. So definitely its mass is going to be lesser than the mass of these two. That is why we have written Mp plus Me minus Mn. So what we are going to do, we will be just putting the values that we have been given. Mass of proton is 1.6725 into 10 raised to the power minus 27 plus Me. Your mass of electron is 9 into 10 raised to the power minus 31 minus mass of neutron. So your mass of neutron that has been given is again 1.625 into 10 raised to the power minus 27. Now you can see that these two masses are equal, so we can cancel them out easily. What you are left with? Delta M equals to 9 into 10 raised to the power minus 31 kg. This is your mass defect. Now if we want to find out the energy released, I have to multiply it with the square of the speed of light. So let me just do that for you. E will be equals to delta M, that means into c square. Speed of light is denoted as c, and c is nothing but 3 into 10 raised to the power 8 square. Now your energy in this case is in the, let me just focus on one thing, because I have to find out the energy and we are having different unit of energy. Let me just focus on the options. What is the unit that we have to find it out? Okay, so we have to find out the energy in the mega electron volt, right? So here whatever will be the value, your value will be in the joule. If you want to convert it in the electron volt, you can say that 1 electron volt equals to 1.6 into 10 raised to the power minus 19 joule, right? So if you want to convert it into the electron volt, what you have to do? You have to divide it by 1.6 into 10 raised to the power minus 19. That will be in the electron volt. Now if you want to get the answer in mega electron volt, again you have to multiply here by 6. Now the energy is coming out to be in your mega electron volt. So 9 into 9, if you will be multiplying it, you will see that your answer for this will approximately came out to be 0.7 mega electron volt. 9 into 9, 81. 81 divided by 1.6. So something your answer will be in 0.75 range, because 10 raised to the power minus 31, 10 raised to the power 64 minus 10 raised to the power minus 19 plus 6. So if you will be watching this, definitely your answer will be coming into this range. Now what we have to do, we have to just verify whether we have just reached at the correct point or not. So okay, I can see that we have been given 0.73 mega electron volt as the correct option. So because I can see that our range of answer is 0.75. So we can say that definitely the answer will be coming into this range, because all these options are definitely very much far away from the answer. So 0.75 or 0.73 will be your correct answer, right? So yeah, now we are done with this question. We will be now moving towards the next question. But before moving to the next question, what I want to tell you is that the beauty of the question is, this question was very much simpler. But the beauty behind this question is this thing, delta M. How are you going to find this delta M? If you know the concept of binding energy, the mass defect, then you are able to do this formula by your own. Because as we know that if something is getting broken down into two components, definitely their masses will be greater than the mass of the one from which it is breaking down, right? So definitely this is the correct formula. Now we will be looking to the next question, that will be the question number 7 of the session. Okay, So the question number 7 says that energy released in the fission of a single isotope of uranium U-235 nucleus is 200 mega electron volt. From the uranium U-235, from one single uranium nucleus, energy released is, from one U-235 energy releases 200 mega electron volt. Now the fission rate of a uranium-235 fueled reactor operating at a power level of 5 watt is what? Power has been given as 5 watt. Now what we have to tell? The fission rate. So basically we have to find out this N. Let me just tell you one thing how we are going to proceed for the question. As I have given the energy for one uranium nuclei. So energy in this case is 200 mega electron volt. Now if I want to find out the number of fissions that is taking place, the fission rate that we have to find, what we are going to do? We are going to multiply the number of nuclei which is coming out from this fission multiplied by this energy, that means the total energy, that will be equals to your power. So from there, from this formula, what you are going to do, you are just able to find out your N. Definitely we are going to proceed in the same way. So I will be starting with this energy as it has been given in the mega electron volt. First of all, I am going to convert it into the joule. So let me just say if energy with me is 200 mega electron volt. Now as you know that, again I am going to write over here one thing, 1 electron volt equals to, isn't it? Now if you want to convert it into joule, so you will be having 200 into 1.6 into 10 raised to the power minus 19. Okay, because this is 1 electron volt and this is mega electron volt. So first of all we will be writing it as 200 into 10 raised to the power 6 electron volt. So now what you are going to do? Now your energy will be coming out into the I think this must be your energy that will come out to be 3.2 into 10 raised to the power minus 11 joule, right? So now we are having this energy with us. What we have to do is we have to find out the N. Now let me tell you how will we be finding out this N? As I told you one thing, the total energy with us is in the joules right here. Suppose, let me just write over here one thing, let N number of nuclei is coming out in the fission. Then in that case, what we are going to do? If we are multiplying this N number of nuclei with the energy of one nuclei, that will be your total energy. This is the energy for one nuclei. So total energy will be when you are going to multiply by the number of nuclei with this. So N multiplied by 3.2 into 10 raised to the power minus 11 will be equals to your power. So your power has been given as 5 watt. Now if there is a doubt in your mind, how are we going to write this? Let me just tell you one thing. What is the power? Power is nothing but the energy generated by all these nuclei. So what we have done? We have been given the energy for one nuclei and we are supposing that these are N number of nuclei, so total energy will be this. So N will be 5 divided by 3.2 into 10 raised to the power minus 11, isn't it? And so you will be having your, if you are going to divide this 5 by 3.2, so your value will came out to be 1.56 into 10 raised to the power 11. Now we are having our number of nuclei as this. Let me just see what are the values that have been given in the option. Before that, let me just say you one thing. If they are speaking about the fission rate, so the fission rate is what? Fission rate is the number of nuclei generating out of this fission per unit time. Fission rate is number of nuclei coming in the time. So definitely if we are speaking about the power and the fission rate, that should be in the per second. So this much of number of nuclei are coming out per second. So that means this will be the rate of the fission, right? So this is how we are going to find out the rate. Now let me check. My answer is 1.56 into 10 raised to the power 11 per second. So yeah, I can just see here B is the correct answer for this, and I am going to tick over this. So yeah, this was the way how to attempt this question and how to just think about the question. Again, you are going to say that for the JEE main level, this question is very much easier. But let me just ask you one thing. If you are not given the solution, then is it easy for you or not? I don't think so. Because if you do not know the concept, if you do not know how to proceed, you are not going to reach at your target. So let me just scroll the next question. We will be moving towards it. Okay, so the next question, what I can see over here is that the intensity of gamma radiation, this is not Y, you can just convert it into gamma. This is like this. So the gamma radiation from a given source is I. On passing through 36 mm of lead, 36 millimeter of lead, it is reduced to 1/8. What will be the thickness of lead which will be reduce the intensity? What we have to find? Which will reduce the intensity to I/2. So let me just start by saying one thing before the question, and that is, do you know any formula which will be having a relation between the intensity and this depth, the depth in which it is entering? Let me just tell you one formula which many students normally they skip that out, and you have to focus on each and every formula that has been given in the corners of your book. So let me just say, where mu is your, if I am speaking about the thickness and intensity, your formula will be I equals to I naught e raised to the power minus mu x, and mu is the coefficient of, you can say, the depth over here, coefficient of thickness, or you can say. So in that case, what I'll just say that in the first case, we will be doing this question in the two parts, as the first case and the second case. In the first case, I have been given that I is reduced by, the intensity was earlier I, but when it is passing through this mm of lead, that means your x has been given as 36 mm. So your I will be reduced to 1/8, right? Or I can write it as I naught by 8. Why I am writing this as I naught by 8? Because earlier it was I, now it has been reduced to 1/8. So that means I am writing it in the terms of initial intensity. So your I has been just converted to I naught by 8. So if I am going to put these values into the formula, my question will be I naught by 8 equals to I naught e raised to the power minus mu of 36, isn't it? So now from here you can see I naught has been cancelled. You are having 1/8 equals to e raised to the power minus 36 mu. How you can solve it now? You can take log on both sides. So if you are taking log on both sides, let me just take into that side. So my log will be here. log 1 minus log 8 equals to minus 36 mu, right? Now from here we know that log 1 is 0, so your minus log e base 8 equals to minus 36 mu. So that means minus minus cancelled. So this is your equation number 1. Now let me just consider the case for the second situation as the second case. In the second case, just move to the question. The thickness of lead we have to find and the intensity has been reduced to I by 2. So we will be putting over here that okay, so what happened? The intensity has been reduced by I naught by 2 and here you have to find out the x. Let me just write over here I has been reduced to I naught by 2 and x we have to find over here. Again what you can do? You can just cancel them out. Now you are left with 1 by 2 equals to e raised to the power minus mu x, right? Now you are going to take log on both sides again as just we have taken in the first one. So that means this term will become 0. You are now left with log e raised to the power e base 2 equals to mu x. Consider this as your equation number 2 and this was your equation number 1. Now if you are going to solve it, you can easily find out the value of x. Let me just do it here. Dividing equation 1 and 2. You will be having log e base 8, this is 8, right? So this is 36 mu and this is log e base 2 divided by mu x. Now the question has become very simpler, mu cancelled and you can write this 8 as 2 raised to the power 3, 2 cube, 36 upon x. Again you can write it in another form and that form is 3 log e base 2 divided by log e base 2 equals to 36 upon x. So log e base 2 and these will be cancelled. You are having with you as 3 equals to 36 by x. So your x will came out to be 12 millimeter. This must be the answer according to us. And now we are going to verify whether this is correct or not. Yeah, I can see that we are having option number D as the correct answer. So we can now take over this. Okay, so we are now done with this question and the beauty of this question behind this formula, this is. So please remember this formula. Again, this formula is important one. You can find the question based on this formula in your JEE mains and advanced, right? So we are done with this question and now we will be moving towards the 9th question of this session. Okay. So I can see that a nucleus disintegrates into 2 nuclear parts which have their velocities in the ratio 2:1. Let me just make one nucleus and according to this question it is being divided into 2 nuclear parts. So this is 2 nuclear parts. So this is your 1 part, this is your 2 part, right? We have been given that their velocities are in the ratio 2:1. That means one will be having v velocity and the another one will be having 2v velocity. Let me just mark it with another color. So this is 2 particles. One will be having v as your velocity, another will be having 2v as your velocity. It is not mandatory to write v and 2v at this place. You can just write over here 2V and there V. So that doesn't matter. Now we will be looking at, we have to find out the ratio of their nuclear sizes. If I talk about the nuclear size, I know that they are speaking about the radius. Suppose this is your nucleus, and if I am talking about the nuclear size, that means I am talking about its radius. So I have to find out this two sizes, or we can find out the ratio of their nuclear sizes. So let me just say I have to find out R1 upon R2, right? Now in the question, if I will be starting, and if you can see this R1 upon R2, definitely there will be one thing that will be coming to your mind, and that is the formula that we are having with us. Let me just remove it first. The formula that we know is R equals to R naught A raised to the power 1 by 3. And if you are going to put these values over here, you can easily find out the R1 and R2. So if you will be having R1 as R naught, because R naught is constant, so it will be only, your R2 will be R naught A2 raised to the power 1 by 3. So from here your R1 R2 is coming out to be A1 upon A2 raised to the power 1 by 3. Now in the question we are not being given this situation. In the question we have been given the velocity, and that we have to apply over here. So let me just see, I know that this mass number A1 is what? Mass number for part 1. A2 is mass number for part 2. We know that your mass number is proportional to the m, because mass number is number of neutrons plus number of protons. So definitely because we are talking about the mass number, so we are talking about the mass. So this is proportional to this. Now what we can do, we can place m1 and m2. Let me just write over here. So this is the mass and this is m1. This is m2. This is the mass of second particle, right? Now I have just written m1 and m2 in place of a1 and a2, right? Because I cannot use a1 and a2 as we have not been given any element so that we can learn about this mass number. Now what we can just do from here, I have been given, actually I have found out this ratio m1 by m2. Now as you can see that this is coming down into the velocity of 1:2. So if I talk about the conservation of momentum, to follow the, or you can say to obey the conservation of momentum, your velocity will be in opposite direction. Your velocities of two particles should be opposite. Opposite in the sense, suppose this is two particles, if one is moving in this direction, another one should be moving in this direction. So that means if it is moving with V, it will be moving with minus 2V, right? Because to just show the opposite direction, we are using negative sign over here. So now if I am just talking about the conservation of momentum, that means m1v1 should be equals to m2 into v2. Now from here m1 upon m2 should be what? It should be v2 upon v1. From here you can see that we have reached up to r1 upon r2 equals to m1 upon m2 raised to the power 1 by 3. And so from here we have find out the m1 upon m2. Now we know that v2 is 2v and v1 is v. Let me just say, and because we know that their directions are opposite, so we are using the negative sign. So you can do this. Let me just repeat this so that you can make it and understand. m1 v1 minus m2 v2 equals to 0. We are using the minus sign because the directions are opposite. So that is why we have got this m1 v1 equals to m2 v2. Now from here m1 upon m2 is v2 upon v1, and you know that v2 is 2v upon v. So you are having 2 upon 1 as m1 upon m2. So if I am going to put this m1 upon m2 over here, that will be 2 upon 1 raised to the power 1 by 3. Let me just see one thing over here. As I am using, in place of v1 I am using v. In place of v2 I am using 2v. That can be the case that I will be using v2v in place of v1 and v2 and v in place of 2v. As I do not know how to apply v1 and v2, I have just put these values. But the another case will be that I will be using, let me just write over here once again. In that case, your m1 upon m2 will be v1 upon v2. And you know that your v1 and v2 are v upon 2v. So that means it has come out to be 1 by 2. And now if you will be putting your m1 upon n2 here, your answer will be coming out to be 1 upon 2 raised to the power 1 by 3. So that thing you should have to keep in your mind, in which direction should we go. Because your answer will be, let me just go back to the options, and I can see that we are having this 2 is to 1 by 3 is to 1 as your first option, and 1 is to 2 by 1 by 3 as your second option. So which one to correct? So that means this thing you should have to focus on. And how you are going to just solve it, you are going to consider the mass, the velocity of m1 particle. M1 particle, say its velocity is v, and m2 particle, its velocity is 2v. In this case, we have seen that m1 particle was having velocity as 2v and m2 particle is having velocity as v. If you know the relation that heavier the mass, slower will be the velocity, and lighter the mass, more will be the velocity. So if my m1 is greater, my velocity should be 2v, and my m2 is greater, so my velocity for this should be 2v. So that you have to keep in your mind. So from my side, I am going to take over 1 is to 2 raised to the power 1 by 3, right? Just go back to the question. We are considering this case because I have considered the velocity of m1 particle as v1, and v1 I have written v, and m2 particle as 2v, and then the ratio has come out to be 1 by 2. If you are going to put m1 upon m2 over here, so your answer will be 1 upon 2 raised to the power 1 by 3, or you can write it in this manner, 1 is to 2 raised to the power 1 by 3. In this case, you are going to write it as 2 raised to the power 1 by 3 is to 1. These are your answers. So you can, I don't think so that we have to just imagine more about this. You can take over 1 is to 2 raised to the power 1 by 3, right? Now we are done with this question, and we will be moving towards the next question, and this question is going to be the last question of the session. Again, if you are feeling confusion in this question, I can just tell you one thing. As we have been seeing that this has broken down into two particles, one is having velocity v, one is having velocity 2v. So I am just supposing that this will be having m2 as mass, this one will be having m1 as mass. In that case, I am just imagining that this is the lighter particle, this is the heavier particle, and by imagining that, I have given the solution for this, right? Now we will be beginning with the next question. Okay. So the next question says that a radioactive sample at any instant has its disintegration rate as 5000 disintegration per minute. After 5 minutes, the rate is 1250 disintegrations per minute. Then the decay constant is what? We have to find out this decay constant. Now let me just tell you one thing before beginning the question. We know that because they are talking about the rate of disintegration. So by just listening that, by just reading that, I know that rate of disintegration, or you can say the activity, is lambda n. And also you know that n equals to n naught e raised to the power minus lambda t, right? So these two equations we are having. What I can just do this, because I have been given this disintegration, I have been given this rate of disintegration, and I have to find this disintegration constant. So I am going to just put this value over here. So my dN by dt is lambda n naught e raised to the power minus lambda t. In place of n, I have just written this statement, right? Pretty easier. Now what you can do, we have been given in the first case, let me just again do it in two parts. At any time, at say t, time t, the rate of disintegration per minute is 5000. So your dN by dt is 5000 per minute. Now, so your equation will become 5000 equals to lambda n naught e raised to the power minus lambda t. So this is your equation number 1. Now let me just consider the second case. In that we have been given after 5 minutes. So earlier the time was t, but after the 5 minutes, the time will be t equals to t plus 5, right? Now your disintegration, rate of disintegration, that has been given as 1250. So you are going to put it as 1250. Now again put this equation, sorry, 1250 equals to lambda n naught e raised to the power minus lambda. In place of t, you are going to put t plus 5. Now you are having two equations with you. What you are going to do, you have to find out this value of lambda. So now what we are going to do, just look at this. Okay. Again you can do one thing, dividing equation 1 by 2. You will be having 5000 divided by 1250 equals to lambda n naught e raised to the power minus lambda t divided by lambda n naught e raised to the power minus lambda into t plus 5. Right? Now you can see over here lambda n naught cancelled. And if I am going to solve for this, you will see that equals to e raised to the power minus lambda t into what will happen, because we are having minus lambda t minus lambda 5 if I am opening the bracket. So this you are having with you. Now to solve this, what we can do, we will be taking log on both sides, taking log. So you will be having, let me just remove this from here and we will be solving it here. Log e base 4 equals to 5 lambda. So you can do one thing, if you will be writing this 4 as 2 raised to the power 2, will it be okay? Yeah, definitely. So then it will become 2 log e raised to the power 2 equals to 5 lambda. From here you will be having your lambda as 2 by 5 equals to log e base 2. This as your lambda. Now if you will be dividing this 2 by 5, you will be having 0.4, or yeah, 2 by 5 will be 0.4 log e base 2. This is your lambda that we have come to the point. Now we have to verify, this is not 6, this is 0.4. Now we will be verifying whether this is the correct or not. Okay, so we can see that option number A, the first one, is the correct one, and the approach how to proceed in this question is nothing but these two formulas. So we have started with this and we have reached to a point. Yeah, this was the question that will based on the decay constant, right? So we are done with this question, and now we will be meeting again in the next session where we will be meeting, where we will be doing the question based on JEE advanced pattern. Till then you can just keep practicing, just keep revising. Do not forget to practice regularly so that your ship will be going into the smooth motion, right? So just take care of yours.